All right, welcome to this explainer. Grab your tool belts because today we're getting totally hands-on. This is your definitive step-by-step guide to mastering topic 3, constructing, assembling, and installing timber external stairs. Whether you're just putting together a simple access flight or you're tackling a massive multi-level structure, the principles of safety, stability, and sequence that we're going to cover today, they're absolutely vital. Now, everything we're going over is pulled straight from your official Genesis International College Learner Guide. Basically, we're taking the technical manual and dragging it right out onto the job site with us. This whole explainer is purpose-built for you, the carpentry students of Genesis, to use as a really practical, real-world guide for your upcoming assessments. Okay, let's dive right into this. Here's our mental roadmap for the build. 1. Fastening the main stringers. 2. Securing the stair treads. 3. Installing lateral hardware. And 4. Ensuring structural rigidity. Simple enough, right? But hey, before we attach a single piece of timber, we need to ground ourselves in the basic anatomy. Take a look at this breakdown. Up at the top, where the stairs actually join the deck, you've got your landing newel post. Then, depending on how long your flight is, you might have an intermediate post right in the middle for that extra bit of support. And finally, down at the bottom, sitting nice and secure on the ground pad, is your bottom newel post. Knowing exactly where these posts sit is crucial, because they are literally the structural backbone we're about to attach this whole shebang to. All right, phase 1, fastening the main stringers. This is the exact moment your project stops being a pile of wood and actually starts looking like a staircase. Securing those stringers is all about creating a permanent, heavy-duty connection between your side supports and the rest of the building. And the secret here? Sticking to a strict, unvarying sequence. Step 1, position your stringer so it's perfectly flush with the finished floor level. Step 2, verify your line in level. You've got to make sure it's not twisting or bowing on you. Step 3, pre-drill your holes. Do not skip this or that heavy structural timber is going to split. Step 4, fix those main connections by bolting the top to the landing joist first. And step 5, tighten all your fixings until the washers are pulled just slightly into the wood, nice and snug. Now, while you're working through those 5 steps, you have to actively manage your stability. Remember, we're dealing with timber here. It's a natural material. It likes to shift, bow, and twist while you're working with it. So you want to use temporary spreader boards nailed between the base of the stringers to hold your exact width. Establish a really straight string line so the stairs don't end up looking cranked. Apply some diagonal bracing to stop any side-to-side sway while your concrete footings are curing. And, of course, always perform your 3-4-5 squareness checks. It's an absolute game changer for keeping things true. Okay, with the frame locked in, we move right along to phase 2, securing the stair treads. So we're moving from the structural frame to the actual horizontal surfaces people will be walking on. And you generally have 2 ways to support these treads. On one hand, you've got your traditional housed stringers. This means cutting precise grooves, applying a good external grade construction adhesive, and driving in wedges. It's classic, it's highly effective, and it's specifically designed to kill any squeaks. On the other hand, we have modern metal brackets. This is where a metal shelf is surface mounted underneath or on the side of the tread. It's an incredibly strong alternative if you want to skip cutting all those grooves. Now, what's really interesting here is that if you do go the modern bracket route, you can't just slap any old piece of metal on there. You've got to check for 3 very specific things. First, a thick galvanized coating so it doesn't rust out in the weather. Second, properly sized pre-drilled holes that actually match your bolts. And third, a load rating that meets the specific demands of your stair design. Hitting these 3 points guarantees your hardware is fit for purpose and won't fail or corrode on you down the line. Moving right along to phase 3. Installing lateral hardware. Now you might be wondering, hey, why do we need extra hardware if the treads are already secured? Well, to maintain a uniform width after years of heavy foot traffic, through bolts with threaded rods provide some serious shear strength. A galvanized threaded rod that spans the entire width of the stairs literally pulls those stringers tight together, locking the treads firmly into place. This isn't just a nice to have. It's exactly what ensures your staircase meets the super strict National Construction Code load requirements. Once it's all tightened up, you just trim off the excess rod with a hacksaw for a nice, clean finish. And finally, that brings us to phase 4, ensuring structural rigidity. Up until now, we've essentially built a really well-assembled frame. But this phase is where that loose frame officially becomes a permanent, unmoving part of the building itself. Let's set the stakes here. Racking is what happens when stairs tilt sideways under the pressure of people walking up and down. We absolutely do not want that. What we are after is structural rigidity. That's the ability of the staircase to remain stiff and completely resist any movement, sway, or bending for its entire lifespan. That's the goal. To hit that ultimate level of rigidity, we follow a strict permanent anchoring sequence. First up, position and re-verify your plumb and level against the deck ledger. Second, drill your pilot holes nice and deep into the landing joists. Third, secure the top fixings using heavy-rated structural fasteners and nice large washers. Fourth, anchor the base of the stringers, or the newel posts, to your solid, ground-level footings so the stairs don't just sink into the soil over time. And finally, seal up those joints. This high-strength connection right here is what stops the stairs from ever sliding away from the building. But wait, even after bolting the top and bottom down, a really tall staircase might still have a little bit of side-to-side wobble. To completely eliminate that, you need to identify any areas lacking stiffness and install permanent structural supports. We're talking diagonal bracing, lateral ties, knee braces, and blocking. Honestly, these are the unsung heroes of carpentry. They are what lock in that perfect plumb alignment forever. And this brilliantly illustrates how you'd actually apply these on site. It's straightforward, but so critical. A piece of timber cut at a 45-degree angle acts as a diagonal brace, and you fix that right across the frame with structural screws to kill any leaning. Alternatively, you could use a lateral tie, which is basically a horizontal galvanized strap, and bolt it directly from the newel post to a floor joist. That will strictly prevent any side-to-side movement. So as we wrap up this Exploner, I want to leave you with something to really chew on before your practical assessment. How could skipping just one temporary structural stability check, like, say, forgetting to use a spreader board or skipping a quick plumb check, compromise your entire perfectly cut stair layout over time? Remember, all those perfect cuts only matter if the final assembly is rigid. Keep that in mind, never cut corners on your bracing, and trust the sequence. Thanks for joining me on this one, and good luck out there on the tools.